Hello everyone, welcome back to our channel XDev Pro. Today we are going to tackle a new LeetCode problem called circular array loop. This problem is perfect for testing your skills in detecting cycles and handling complex array manipulations. Mastering this problem will not only boost your problem solving abilities but also prepares you for coding interviews where understanding circular data structures and cycle detection can give you a significant edge. So let's dive in and crack this puzzle together. So let's start with the problem statement. So what I'll do is I will directly jump into the example and I'll show you what does it mean. So here, if you see the first example, how will the movement happens, right? How will the movement happen? So if nums of I is positive, moves nums of I steps forward, and nums of I is negative, then nums of I steps backward. Suppose if you're traversing from here, then it is the value is 2, right? So that means you have to move 2 step forward. So my next jump would be here. Okay. So similarly, value is 1, so it will jump only once, one step. So value is 2. Now, if you try to jump 2, you can see that there is only one element, right? You can't make twice jump. It will be out of bounds. But it is said that moving forward from the last element puts you on the first element, okay? Because since the array is circular, so that means when you jump from here, you will directly reach here, 2 step. So one step and then second step, okay? Similarly, it is said that moving backward from first element puts you on the last element, okay? So if you'll see in the second example, -1. So moving backward from the first element will put you in the last element. -1 in one step is this side. So if you see this one, so if you're traversing from here, then -3. So it will be 1, 2, and then 3. It will directly jump here. So it will directly jump here like this. Okay. So that's how movement happens within the array. And so they have given 3 conditions to detect whether there is a cycle in nums or not. Let's understand this condition with an example. So there are 3 conditions that is given. So to simplify this, I have written here that first it is repeat. Okay. So for example, in the first input, if we traverse from here, so it will jump 2 direction, right? So 1, 2. So first it has visited here and next it is visiting here. Okay. Now it will jump one array. So it will be here. Now next it will make 2 jumps. Okay. So it has visited this. Now next it has made 2 jumps. So when it is jumping here twice, then it will reach here. Okay. So now you see that 2 is repeated, right? So this element is repeated. So this meets our first condition. Okay. And next is all the elements that were involved in the traversal are in the same direction or not. So what do I mean by same direction is either all are positive or all are negative. Okay. So positive means all the movement is towards the forward direction, and if it is negative, then all the movements are towards the backward direction. Okay. So here you can see that all the elements are positive. So it means the second condition also. That means it is traversing towards the same direction. Okay. And third is whether the cycle is greater than 1 or not. More than one element are involved or not. Yes, it is. So that's why it is satisfies all the 3 conditions of being a circular array loop. So it should return true. Okay. Now in the second example, if you see, we'll traverse from here -1 and we'll see that negative means in the backward direction, right? So it will move here 5. Okay. So 1 have been encountered and 5 have been encountered. Now since it is positive, it will move towards the forward direction. So forward direction means 5 steps ahead. So first step will reach the first element, second, third, fourth, and fifth. That means moving 5 step will point to the same element. So at this point, we have encountered the element that we have encountered earlier, right? So now if we'll check here, then is it repeating? Yes, it is repeating, right? The 5 is repeating. So we have traversed -1 and then 5 and then once again 5. Now are all the element positive or negative? No, right? Because first element was negative and second element is positive. That means first element moved towards backward direction, but the second element move towards forward direction. Okay, so this condition is not satisfied, and at the same time, at the same time, the cycle is also not greater than 1. The cycle is just 1 because this cycle is from 5 to 5, right? So this is the cycle, so this is not greater than 1, it is equal to 1, so this is also not satisfied. So in this case we will return false. Okay, so this is our overall problem statement. Let's look at the approach. So the best way to solve this problem is by making use of Floyd's hare and tortoise algorithm, or you can say fast and slow pointer technique. So what does this algorithm say is you will have two pointer, slow pointer and fast pointer, and fast pointer moves with twice the speed of slow pointer. That means when slow pointer moves one step ahead, fast pointer will move two step ahead. Okay, so and at the end, when slow pointer and fast pointer will meet, then it will indicate that there is a repetition of elements, right? So at that point we'll determine whether there is a circular array or not. Okay, so let's try to understand this approach with an example. So what we'll do here is initially we'll have slow pointer pointing to the first element and fast pointer pointing to the first of element, and in each iteration slow pointer says what is the value here, so it is 2, right? That means it has in first step it will have to move with two jumps, right? So it will make two jump like this and it will reach here, and at the same time fast pointer will make two steps, like in first steps it will move two jumps and reach here, and in second step it will make one jump and it will reach here. Okay, now in second iteration again slow pointer will move just one step ahead, since the value is 1 here, so it will move here, and fast pointer will move two steps ahead. So in its first step it will see that it has to make two jumps, so jumping here and then next jump is here, and in its second step it will see that it will have to make two more jumps, so it will jump from here to here. Okay, so in next iteration slow pointer sees that it has to make two jump, so in one step it will reach here with two jumps, and fast pointer has to make two steps. So in first step it will see that it needs to make one jump, and in second step it sees that it has to make two jumps and it will reach here. Okay, now at this point of time we see that both fast pointer and slow pointer is moving to the is pointing to the uh, same element. So here at this point of time we'll stop, and also we'll check all these three conditions. So is it repeating or not? Yes, it is repeating because fast pointer and slow pointer have met. That means some element have been already visited, so yes, it is repeating. And now are all the elements involved are positive or negative? Since we have visited 2 1 2, all the elements are positive, so this condition also met. Now third is the cycle greater than 1? Yes, the cycle is like this, right? So it is like this, so it moves and reach here, and all the element that is involved here are greater than 1 because there are three elements involved in the cycle, so it is greater than 1. Yes, so at the end we'll return true for this. Okay, so that's the criteria. Now in the first example, suppose for some reason the condition have not met, right? What we'll do is we'll repeat the process for all the elements, or maybe you can say all the unvisited element. So in second example, if you see, initially both fast pointer and slow pointer will be pointing to the first element. So first element is visited, and then move slow pointer one step ahead. So when we'll move slow pointer one step ahead, then it is -1, right? So it will move backward. So backward means it will go here, last element 5, right? At the same time, in that iteration, fast pointer will move two steps ahead. So with this first step, it will also reach here, okay? And in second step, it says that it has to move forward, right? So when it moves forward, it will jump towards the forward direction since it is positive, and it will check that 1 2 3 4 5. So it will point to the same element. Okay, at this point of time we know that slow pointer and fast pointer is pointing to the same element, and circular element is happening here because 5 is again pointing to 5. So now if we'll check the condition, is it repeating? Yes. And are all elements positive or negative? No, right? Because first element is negative and then second element is positive. So no. And third element here, cycle is greater than 1. So, but cycle is equal to 1 since there is only one element involved in the cycle. So this is also no. So now what we'll do, so there are a lot of elements which have not been encountered yet, right? Or which have not been visited yet. So we'll do the same process with the second element. Okay, now what we'll do, we'll reinitialize our slow pointer and fast pointer to point to the second element, and we'll do the same, we'll apply the same logic. That is, slow pointer will move one step ahead and it will reach here. Okay, and fast pointer also in its first step it will reach here, but in its second step it has to move 5 step ahead, right? So that's how we'll go ahead. So when the condition is not met, then we'll check again, we'll check for the next element and reinitialize our slow pointer and first pointer to point to that element and go ahead. And similarly, we'll check all the elements and until and unless we are satisfied. So at the end, if we found that none of the iteration have resulted in all these three conditions, so then we can return false. Okay. Now here, to avoid visiting the same element twice, we'll make use of a set as well. So such that we'll make use of a visited set of index such that the index which have already been visited will not visit it once again. Okay, that is the approach to solve this problem. And now if we talk about time complexity, since each element will be encountered once, right? So that's why we can clearly say that the time complexity would be O of n. Okay. Since each element will be processed once. Okay. Because in first iteration, suppose these and these have been visited. So in second iteration, it will not visit it once again, right? All the elements will be processed only once. That's why the time complexity is O of n. Okay. So let's jump into the coding now. So initially we'll have n, which is the length of nums, and we'll run a loop and we'll check for each element, and for each element we'll first define a slow pointer and fast pointer pointing to that every time we initialize our slow pointer fast pointer to the starting of the index. Now we'll define our direction. What is our direction, whether it is moving towards the forward or backward. Okay, so to do this we'll define a current direction, and current direction would be 1, saying that it is a positive. So if nums of I is greater than 0, that means that then it will be 1, else it is negative. Okay, so we have defined our current direction. Now what we'll do is we'll have to iterate until the slow pointer and fast pointer meets, right? So we'll simply run a infinite loop, and we'll have condition here to break it. So first what we'll do, we'll find our next jump, right? So to do this, what we'll do, get next index. Okay, we'll provide speed and current direction. So we'll have a function somewhere here that will say get next index. We'll take the index to define what is the next index, and also it will define take the current direction. Okay, and similarly we'll also have fast pointer. Okay, So let's define this function first, get next index. Initially we'll find our next index. What is our next index? So what we'll do is we'll have to add the index. So while making the jump, it is going like this, right? So 2, that means the index is 0 here and the number is 2. So 0 plus 2 is 2. So it will point to 2 index. So that's what index plus nums of index. And also it is said that after the last element will come the first element. Okay. So how will we do that? So because it will go out of bounds, right? 0, 1, 2, 3, 4. So from here, if we'll count 2, then it will be 6, 5, 6. So, but instead it should have been here 0, 1, right? So to do this, we'll find the remainder with the length. Okay. So that means at this point, since it is 0, 1, 2, 3, 4, right? So if it is 4 here, then 4 plus 2 is 6. Okay. And 6 percentage the length 0, 1, how many 1, 2, 3, 4, 5, right? 5 is the length. It will give you 1. That is your next index. That is this 0 and 1, right? Which would be correct. That's why we'll make use of this. And so now we'll find our next direction. Okay, what is the direction of this index? It will be positive if nums of next index is greater than 0, else it is negative. Okay, and at this point of time, if there is a direction mismatch, current direction is not equal to, if the current direction is not equal to next direction, then we can return an invalid value, that is return -1. Okay, saying that it is an invalid. And if the third condition, that if the cycle is just one, so if only one element is involved in cycle, that means uh, jumping from here will result to the same index. So index and next index is same, then also it will be invalid. That is, if index equal to next index, so it will be 10 minus 1. Or you can just make an or condition here. So if the direction is mismatch, or if the number is pointing to the same number, then it is an invalid option. Otherwise, we will just return our next index. Okay. So this is our logic to find get in next index. Now here in our original logic, slow pointer we have found get next index, and a fast pointer we have found get next index. So we know that fast pointer needs to move one more step, but before doing that, what we'll do is we'll just check here. So if SP is equal to -1, if it is an invalid index, or FP is equal to -1, that means we don't have to check further, right? We know that it's an invalid. We can move ahead with the next element, that is for -1. Or here in this case, we have figured out that it's an invalid, so we'll check for -2. So in this case, we'll just simply break. So it will come out of the while loop and will run for next iteration. Okay. And if it is not, if it is a valid index, then we know that we have to move first pointer 2 steps ahead, right? So this becomes our first step, and this will be our second step. Okay, so it will move twice the speed of ahead. Now, since in the second step, if fast pointer is again invalid, then we'll break, right? We know that now it's an invalid here, so we'll check for the next iteration. But if it is not invalid, if it is a valid index, if both at this point of time we know that slow pointer and fast pointer have both reached to a valid index, that means they are moving to a same direction and there is no single circular loop. So at this point of time, we'll simply check if slow pointer is pointing to the same number or not. If it points, that means we have found our result. Return true. Okay. So at this point of time, we know that we have met the condition and will return true. And we don't have to check in for any further elements, right? Since we have already found that it's a circular array loop. In other case, when it is breaking, right, with all the invalid options, and it has also checked for all the elements and it has come out of the loop, then we have not found any circular loop. So at the end, we'll simply return false. This is our entire logic. But here there is one more thing, that is we have not considered the visited part. To make sure that the visited elements are not visited, once again we'll have a visited set. So you can say that visited index, okay, it's a set, and every time we're going to iterate, we'll add our slow pointer. So it's visited index, which index have been visited, right? So this index have been visited, and similarly slow pointer and fast pointer both have been visited. Okay, that's how we move forward. And in here we'll say that if this index is in visited index, so if this index have been already visited, then we'll not go through all this logic, right? We'll simply continue and move to the next iteration. Okay. So if I is present in our visited index, then we'll not move ahead and we'll check for the next element. Okay, so it will save a lot of our time. This condition, this logic will actually help you achieving OF and time complexity, because all the elements will be processed only once. So let's run this code. Now let's submit this code. Awesome. And that's how we have successfully solved the LeetCode problem, circular array loop. This problem is excellent practice for coding interviews because it sharpens your ability to identify cycles and manage complex array manipulations. If you found this video helpful, please hit the like button and subscribe to our channel XStep Pro for more coding challenges and interview tips. And don't forget to click the bell icon to get notified whenever we upload a new content. If you have any doubts or suggestions, feel free to leave a comment below. I'd be more than happy to assist. Thanks for watching, and I'll see you in the next video.